We have Cliff Patterson and Dane Wilson have joined us to talk about their telecom design case study. Cliff, Dane, show your faces.
Coming, I
The
swear.
microphone. Hey, there's one.
I swear it's turning on.
There it is.
How's everything, everyone? Can't see myself, but I assume you can see me.
Can see you.
All right, good. Let's go. Let's dive in. Well,
There you
thanks
have
for
it.
having me here. This is my second PostGIS day ever, so I'm really excited to present on this. Today we're going to be presenting, kind of following along with what Justin was talking about. And what we're going to talk about today is setting up PostGIS and QGIS in an enterprise environment, a telecom design case study. And the background to this is I'm Cliff Patterson, CEO of Luna Geospatial. We're a GIS consulting firm out of London, Ontario, Canada. So Dane Wilson is the VP Operations of DFX Technical Services, and he is a specialist in telecom design. And when he came to us, he was looking to move his operation into PostGIS. He had already been using QGIS, already had been using GeoPackage, which was a very good step in that direction. But he had never used this database, so we had to figure out a way of setting this up for him. So what I'm going to present to you today is really our journey together in setting this up. And it's an ongoing journey. There's still a bunch of things that we are working on that we'd like to go through. So the plan for what I'm going to talk about today will be an introduction to telecom design. Dane will give us a little rundown of how this works. And we're going to talk about I'll sort of run through how we built the enterprise database with PostGIS. And then we're going to talk about QGIS integration and some of the various things that we can do when we connect to a PostGIS database with QGIS and some of the ongoing work. So my sort of to-do list of some of the other things I'd like to add to this database. So with that, I'm going to turn it over to Dane to give us a walkthrough on telecom design.
Thanks, Cliff. So there's a few points that I wanted to touch on about what is telecom design. So right now I would say the landscape in Ontario and in Canada as a whole, it's extremely busy, and the reason for that I think is the push for remote work and remote schooling has really been a catalyst for high-speed internet to become more of an essential service, almost the equivalent to having electricity, I would say. What is wireline telecom design? I would say in a nutshell, it's applying customer, manufacturer, and local standards to determine the most optimal design to be implemented that meets the project objectives. So whether that's a fiber to the home build to wire up an underserved community, in the rural space, or maybe that's an overbuild of an existing brownfield community. What do wireline telecommunication designers do? They prepare complete high-level design packages similar to what Justin just shared, like a very similar output. And following along with what Justin had said, taking that customer-provided scope of data, your field survey data, customer design specifications or playbooks, the municipal or LVC requirements and standards, material and equipment requirements and standards, and then geographic factors. So in Ontario, dealing with difficult ground conditions might force you aerial where you might otherwise be buried, water crossings, certain things like that. And then what role does the government play? So both provincial and federal. So as I mentioned before, the catalyst for everybody having high speed. The government of Canada is targeted to connect 98% of Canadians to high speed by 2026 and 100% by 2030. And that's a $3.225 billion budget launched in 2020. And then in addition to that, Ontario has the ASIP program, Access to High-Speed Internet across the province. And Ontario has committed nearly $4 billion to bring high-speed internet access to every corner of the province by the end of 2025.
Interesting. Okay. So with all that said, there's a lot of work to be done. And there's a lot of work to be done, and we have to store a lot of data. We have to produce these projects and have somewhere to store them and be able to enable everything that we need to do, like multi-user editing. So what we did when we first got together was we focused on discuss some of the major challenges. One of the things with software licensing is that Dane, as well as most people I work with, when they sort of make this transition to open source GIS, is one of their main problems is software licensing, and they don't want to build a GIS that's going to eventually cost them hundreds and hundreds of thousands of dollars per year, especially if this is something that they're going to have to scale up and scale down over time. Now, we'd like it, most customers would like to be able to just scale their up and stay there, but the reality is, projects come and go. So being able to scale up and down is something that's very important. As I said, and I'm going to say a few times through this talk, multi-user concurrent editing is the goal, right? It's fine if everybody sort of works on their own little area in a geo package and then eventually you merge that data together. But that becomes problematic, and there's problems that happen with that. It's not real time. You can't monitor progress. There's a million issues when you're working with multiple users using a file-based system. We wanted also to monitor and be able to review work progress. Many employees are working remotely. Many employees might have problems when they approach something. By having a centralized source of truth for all the data, we're able to help employees as they're digitizing. We're able to answer questions quite easily and say, open this project, look at this location, what do I do here? But we're also able to monitor progress, so we can easily open up something like any of the layers and see, okay, well, it looks like we're about 20% done. Next, we're able to integrate field data. This is something that we do rather manually now, but we're looking to sort of integrate this a little bit more, and I'll talk about that a bit as I move on. And sharing progress with clients. So we want to be able to not sort of reveal or hand over the entirety of our database when we're handing data to a client. We really want to give them a sort of denormalized view of the database in time. So our first thing that we talked about when we got together was, do we want to have one schema for the planning data, and there'll be one cable layer, and we're going to put, whenever we do a project, we're going to be digitizing into that one cable layer, as well as all the other layers, or do we want a schema per project? And after a lot of sort of talk back and forth, so I could understand how the industry works, we decided to have a schema per project. It just made more sense because a project is a project, and will rarely will we need to tap into data from one project into another project. So within our main tables, so within each project schema, we have about 34 different tables that are all being digitized. Some of them aren't being used all the time. We sort of will have some temporary layers that we're going to digitize. We have things that we use for printing when we're producing an atlas of the area of interest. And we also have a variety of other tables, including non-spatial tables. We have a centralized schema that contains all of our lookups. So all of our foreign key tables exist within one schema. And this has an advantage, of course, right? Because if we want to add one new value to a drop-down menu in QGIS, it's quite easy just to add that value to lookup, and then every single one of our projects will now have access to that lookup value. We also have a base map schema. Obviously, we have things like, road layers. If there's any parcel data that's going to be used for multiple projects, we'll store that within the base map schema, as well as, water courses, anything else, any provincial data that we might need for a project will be stored here. Our template plate schema is where the basic project lives. And this allows Dane to go in and make changes to the QGIS file, modify the print layout, add new layers if we add anything new to the database, so that whenever we create a new project, it's being created from these templates. Now, lastly, we have an audit schema that contains one table that records all of the changes that happen within the database. So, so that we can look back on this and see what's actually going on, what has been created, edited, and so on. So in terms of our lookup tables, we have 59 lookup tables in total. This grew from the beginning. Dane and I started chatting, and next thing we knew it, everything that could have been a drop-down menu turned into a lookup table, which was great. And this is what's required when you're working within QGIS. One of the things that's obvious is that, you know, if you were going to do this, if this was going to be just a web map application, we might store all of these lookup values in one table and have a sort of type field to be able to filter through the different ones. But because QGIS really does require an individual table for each related value, we had to do it like this. So it's used by all projects, as I said, so it's some central source of truth for all of these lookup values, which is quite nice. We also use trigger functions extensively, a lot for the easy stuff and a lot for sort of running these sort of spatial SQL queries like calculate length and area, the easy stuff, transforming coordinates, DPSG 4326. And, you know, we are summing values, this field plus this field equals this. But we also do some other things. We do some spatial queries, which are fun. So we'll do things like get the pole ID that's closest to the start and end of a cable. So this is done automatically when you save, and this value is stored within the cable table, let's say. And then we'll also be able to get things like the owner of the nearest pole. So this saves the digitizers a lot of time. So whenever possible, I always said, let's put as much logic into the database as possible. Now, previously, a lot of this was stored when this was being done with a geo package. A lot of this was being done on the QGIS side. So it would be done in a form, but the logic lived within the QGIS project. We've moved all that logic into the database. So now the beauty of this is that if we ever do turn around and build something like a web map application off of this, our logic is now centralized within the DB. Then the other thing that we did was some complex concatenations that had to take place for labeling purposes. So we'd grab a series of columns and do it, and there would often be some conditionals thrown in there. If this value is this, label this, bring it all together. And it got really complicated doing this within the QGIS environment. And again, I thought, you know what, why don't we just create a label field within the DB? We'll create a trigger function. We'll automatically add everything to it. And it was just that easy to do it within SQL. I have a hard time not doing things in SQL when I need to do something like this. So the audit table, there's sort of two ways that we audit the database as we go. The first is the audit table, and it just logs all inserts, updates, and delete actions on the entire database. This is nice for a variety of reasons. One, we can restore individual values if we need. If somebody accidentally deleted a point, we can go in here and grab it without having to restore from a backup. The other thing that we can do too is we can produce summary statistics. We can sort of see how much work has been done on a specific project over the course of days, weeks, months, and so on. But also each table has these sort of metadata fields that preserve, you know, created by, date created, modified by, and the date. Users is a pretty simple user setup at this point, but it's something that we can scale more in the future. The big question was, do you want every editor to be able to edit every project? And the answer was kind of yes at this point, because every editor is probably going to be working on every project. So we have three main groups. We have an admin group, we have a read-only group, which can read all the different projects, and we have the editor group. So again, fairly simple setup for users, but this was a big thing we had to develop. We wanted to create a simple script that we could run, we could modify slightly, and produce a new project. So produce that new schema with all 34 tables, all trigger functions would be in place, as well as the default symbology. So this is exactly what we did. The script is like about 3,000 lines of SQL, and it produces the project schema, the main tables, the trigger functions. It sets the project coordinate reference system. It grants permissions. It adds the data audit trigger for every single table within that new one. And the cool thing is it takes the symbology. So it'll actually tap into the default symbology that we store in that template schema, and it will apply it to all the new tables that we created in the new project. Yay, automation. So now we get into the QGIS side of things, all right? So we have this database set up. We'll be able to create projects quite easily. What's the next thing that we have to do? We need to create the new connection. And the best way of creating a connection to a PostGIS database in QGIS is by using the configurations. So this is something you should use instead of using basic authentication. Now, when you use basic authentication within QGIS, you're storing your credentials in the QGIS project file. So that simple XML file, if you opened it up, you would see your credentials. So if you share that project with somebody else, unfortunately, you're sharing your database credentials, and they're loading all the layers from the database using your credentials. So all the user permissions you've set up are now out the window, because now if you have admin, they have admin. So we use configurations to keep the credentials private. That's the main reason. And everybody, there's a sort of like a configuration ID that is used. You can have different ones for each user, but it's a lot easier if you use the same one. And all PostGIS credentials are saved into the QGIS profile. So that's a big thing to know too, is that if you create multiple profiles within QGIS, you're going to have to recreate that connection to PostGIS. So permissions and viewing tables. Beautiful integration here. This is one of the things that's the nicest, is that whatever permissions you've set up on tables, you will see that within the QGIS environment. So in this example, the super user can see, edit, do whatever they want on every table within this admin schema, while Sarah, a member of the editor group, can only see one layer, the other admin stuff layer that's within this schema. Now Phil has read-only permission, has no permission to this admin schema. So he can't see anything, and he can't see, can't edit, can't access anything. Now for editing, this is another thing that's really well integrated within the QGIS environment, is that if you do have editing permissions, you will see this little editor icon, this little pencil will show up, and you're going to be able to click it and edit and save your edit. So again, this example, the super user and Sarah, who's a member of the editor group, has the ability to edit this parcel data set, which is highlighted. Whereas Phil, who we don't trust, is only a member of the read-only group and does not have access. So this is how it works within this DFX database. So another thing that we've integrated here would be centralizing the vector symbology. You can save symbology directly into PostGIS, and you can save multiple styles per layer, which is really handy to have, especially if for one client, the line has to be blue, and for another client, the line has to be orange. You can save those different styles in the database, and instead of having to recreate them, you can just call them back. Now it's saved within the public schema in a table called layer styles. So once you save one table as default, it will create this table within the public schema, and all of your styles will be saved into that. So in an enterprise environment, you really don't want everybody to have access to this or have write ability on this table. So in QGIS, I always recommend, or sorry, in the database, I always recommend that we only give admin permission to modify these default styles. Now we can, possibly open that up to editors in the future, but we really want all of our maps to look the same. So we at least want to have some sort of control over who can create these styles. So QGIS integration, next one is to centralize QGIS projects. Now, of course, you can save projects within the database. This is a really nice development that happened within the QGIS environment. So as we're adding all these layers from the database, we can save the QGIS project directly. And because we're using the proper way of connecting to a database and using storing our credentials in a configuration, any user who has access to this schema is now able to open up that QGIS project. Projects are saved into a table called QGIS projects. Now that will be created within the schema when you first save. So in this example, we're saving onto the DFX production database into the template called, into the schema called template, and then we're calling our project DFF template project version 2. QGIS projects are read-only for all users. This is the way we've created it. This was by design, of course. Because the last save wins. And if everybody's able to access and save, inevitably somebody is going to save over somebody else's data, right? So if we have two users opening it up, it doesn't lock the file. That's something I've been thinking about a lot and how we might do this. So the solution that we've had right now with staff is to save a default template for a project within the project schema. The user is then able to save that onto their local system, and then they're able to modify it. Now, why would they want to modify it? One of the main reasons of where you're working. We might have the project zoomed out to the whole project area, but if somebody is working just within a small area, they might want to press save and come back to it later if they open up the project. So QGIS integration. The other thing that's nice here is that we can create custom forms. I love making custom forms. It's something that makes it so easy to enter data. The first thing I always do is I create this tabbed interface and I start splitting up our fields within this interface, right? Just to make it a little easier to categorize, I guess, the different types of data that we will be collecting. Now, QGIS has the ability to create a number of different elements when we're doing data entry, everything from checkboxes to numeric input, text input, date input. But one of the most important things that we've done in this project, and again, think back to how the database is designed with that one schema that contains all of the lookup tables, is that we create these value relations. And now when you create a value relation in QGIS, it actually looks up to that table because you load the table into the QGIS project. What's very neat about that is that again, you're able to add a new value to that lookup table. Every project will have access to it. And you can see here in this example, our placement drop down, and it appears as a drop down, of course, within the form is looking up to this CA placement table that we have that has 3 values. And if we add a 4th, that value will be there. So every single drop down that you see on this form is referring to some sort of lookup table. So what's cool also is when you save the default style for this layer, it saves the form as part of that style, of course. But it also saves that relationship. So when you go and add the cable file in QGIS, it will automatically add the cable placement table, the category table, the construction table, and the type table, which is a very neat thing. All right, print templates, getting close to the end. So this is the sort of thing that we're working on right now. I think we're almost there. So we're working out print templates for all the different projects, and those are also saved to the project, and the project is saved to the database, so everybody within the organization has access to it. We do have to create different designs for each client. They're slightly different for each client that we work with, so we have to create all 3, but that's really easy. You just create all 3. Create one, make a duplicate of it, change whatever you need to change, save it. And then when you're creating a new project, you can just go in and delete the ones that don't apply, and you'll only have the ones you need. The other thing that we're doing a lot is using the atlas function within QGIS. So again, we have a polygon table that's stored within the database that allows us to create different print views, let's say, over the whole project area. And the atlas allows us to really quickly spit those out into a PDF format. So exporting data is another thing that's important. I just wanted to kind of show you this because I think this is really cool, even though it's really simple. Is you can actually export layers containing foreign key lookups. I know that doesn't sound huge, but it is in a sense, right? Because so instead of having to run a query, and you saw all the lookups that we have within these tables, as opposed to having to like denormalize this and creating all your joins and doing all this, instead of exporting the integer values for all of these lookup fields, you can actually export the values. So when you're exporting a layer within QGIS, if you check this, replace all selected raw field values by displayed values, you're going to get the values from the lookup tables, which is a very nice way of sharing data as opposed to handing somebody a whole whack of integers. So what are we working on now as we move forward with this project? The big thing I've been doing now is thinking through the process of denormalizing a lot of these tables for when we hand off to the client. As part of that new project script that we create, I want to create a bunch of materialized views. Why materialized views? I create materialized views for these denormalized tables because I want to share them with something like GeoServer or GeoNode so that the client can see the work in progress, but I don't want the client to see every step of the way. I want to be able to refresh the materialized view and say, okay, now you can check it again. You're going to see all the new work that we just did. And by having that simple command just to refresh the materialized view as opposed to rewriting and regenerating a new table or something like this, It's really fast and easy. And then even within the QGIS environment, you can create a little tool that just refreshes all of your materialized views. So that's sort of on the go and something that we've been thinking through. The other thing we're working with is the guys over at Lutra Consulting. We're working on integrating merging maps into this system where we can have field data collection streamed directly into our PostGIS database. And lastly, that big long script that I wrote to create a new project, we're just going to create a custom tool in QGIS where you're going to be able to say, you know what, the CRS is 26917. The name of the project is this, and go. And it's just going to create the entire new project for the user, and everyone will be happy. So with that, this is where we're at with this project. It's kind of a nice case study because we spent a lot more time in the design than I even thought when we started this. And as we move forward, we're continually finding more things that we have to sort of tweak and fix. So hopefully by next PostGIS day, we're going to have a well-oiled machine to show you. And that's it. Any questions? I will look in the question section.
Pretty quiet so far.
I don't see the question. Oh, here it is. I see it. Question section.
So database-driven UIs, right?
Yep.
Yep, everywhere. You got to the point where they just sort of self-generate, they're like a declarative form format,
Yeah.
Are you hand generating them and getting mostly getting drop downs off of the database?
Oh, sorry. What? Can you ask that again? Sorry, I didn't hear the beginning part. My volume was too low.
Database generated forms.
Yeah.
Is there like a declarative format for forms so you can like literally just have them show up, or do you have to manually set them up with their little lookups
with each time? Well, see, this is the thing, is that because we have that temp, this is how we designed it. All the forms live as a default style within the template schema.
Yeah.
So that when we regenerate a new schema for a project, we're pulling the style, it's just a row. We're pulling that row and basically just renaming the schema of that row. We're copying that row, renaming the schema to the new project schema. Boom, that's the default style for cable now. So the forms are saved within that style. So now when the user even if the user goes into the schema and just adds the cable layer, that form is already saved.
Right. So you got to do it manually once, but it gets reused project by project by project by project.
Yeah, but the beauty of this is that now Dane can go in and change. If he changes anything in that template folder, if he decides, you know what, I want to add a new field, or I want to change the name of this, every future project will have that exact same style.
Right.
The problem is going back to previous projects, is that we would always have to go back manually and fix those.
Yeah. I got a question from Simon Koblar. What is the benefit of using separate tables for drop-down values instead of filtering one big table by layer column?
That would be nice, but to my knowledge, that capability is not within QGIS right now. Is that you would be looking up? I'm not sure if you could filter. I don't believe you can, but it would be nice just to have one table that we could call and then filter by a certain type column. But I don't believe that functionality is there right now. I haven't found it yet. If it is, sorry, but it is. Let me look it up, Simon. Thanks. We also like having them separate. It's kind of an easy thing to have them as separate, because then we can open up that individual table and then edit it, add more. Yeah, we kind of went back and forth on that as well.
You got a question from Rob Wilson?
Yeah.
When someone saves the QGIS project locally to edit project layouts, do they then just save a newly named project to the schema?
Rob, they don't have permission to save within that schema. I guess theoretically, we could create a separate schema for each one of our editors and then have them allow them to save their projects within those schemas, but we sort of lock out that because we don't want somebody to resave over our template. So again, this was something we talked about too, is giving them the ability to save within those individual schemas, but we decided to sort of lock that out. And yeah, they'll save it on their local, and worst case scenario, if they lose it on their local, the template is always there in the database. They can always make another copy and save it locally. Mergent versus Q field. Mergent has a really nice sync function. I have clients also who use QField, who swear by it. There's different advantages for both. Tons of information out there if you sort of want to make the decision whichever one you're using. We sort of commit to Mergent maps. I kind of like it. I like there's a nice little PostGIS sync tool that will sync data directly into PostGIS, so it's kind of handy. Next question, Marco. Is there any way to create a project level authentication so that a login prompt is requested when opening the project? Not sure. I'm not sure about that one, Marco. I think that you would already be authenticated in the database if you were going to see the project that lives within the database. So I think that's where the authentication comes in, if I'm understanding your question correctly.
And that's time.
And that's time. Okay. I'll answer the rest.
Thanks, folks. Thanks, Cliff. Thanks, Dane.
Thanks a lot.